this video, we will be discussing about counting words with a given prefix. You are given an array of strings words and a string pref. Return the number of strings in words that contain pref as a prefix. So what they are saying is that in the input, we are given an array of string, which is words, and we are given another string, which is pref. Now we need to find out that how many words are there in this array, which starts with this particular string, basically, which have this particular string as their prefix, right? So this problem is kind of similar to the yesterday's problem. So what we can simply do over here is that we can take each of the words, right? We can take each of the words and we can check whether they are starting with this particular string or not. Now there are multiple ways of identifying it. So let's see. So this is the brute force approach that we are following. So we will take each of the word, right? So basically we would be first considering pay, right? So what we can do is that we can take a variable I, right? And we can keep it at the starting of both the strings, right? And then we can compare. Is this equals to this character? No. Then that means this string is not starting with the prefix, right? So we will consider the next string. Next is this attention, right? So we will keep I over here and I over here. Now you will see that this and this is matching, right? So we will move I forward, right? Since we are taking only one pointer over here, so it will be moved in both the strings, right? Now we will see it is again matching, right? So now we will move our I forward. So here it will come at the end and here it will come at T, right? Now as soon as one of our I reaches the end of any of these two strings, we can stop, right? And after stopping, if this I has reached the end of the prefix, then that means this string is starting with this particular string, right? So in this particular case, our I has reached the end of the prefix. So we can say that this string is having this particular string as its prefix. So we will count it. So the count becomes 1, right? Then we see for the next string. So I will be here and here. Now these are not matching. So we will stop here itself, right? And we have not reached the end of the prefix, right? So then that means this is not to be counted. Then we'll come here. I will be here and here it will be at A. Now this A and A is matching, so I will move forward. Then this T and this T will also match, and then I will move forward. And then here I will reach the end of the prefix, so we will count this as well. So count will become 2. This is our answer, which we need to return, right? So this is pretty much what we had to do. So let's quickly look at the code. So first of all, we can take a variable count, which we will return, right? And then we can run a for loop for string word in words, right? Now for checking whether this is a prefix or not, we can create another function which will return us a 0 if it is not a prefix and a 1 if it is a prefix. So we can simply add it in our count, right? So if let's suppose the function is has prefix, so this will return us 0 if the string is not starting with that particular prefix, right? So 0 would be added, otherwise 1 would be added. And in this we will pass the word and the prefix string that we are given, right? And at the end we can return this count, right? Now here let's create this function. It will return us an integer. Name is has prefix. This is receiving a string and it is receiving our prefix, right? So now inside this we'll take a variable I, right? We'll run a for loop. We will initialize I to 0 and then it will go till I less than string dot length and I less than prefix dot length, right? And then we'll do I plus plus at each of the point. Now we'll check that if at any point the ith index in string is not matching the ith index in prefix, then we can return a 0 from here itself because we didn't find the prefix, right? And then if we are coming out of this loop, then that means I has reached to the end of either of these two strings, right? So we'll check that if I is not equals to prefix dot length. Basically, I has not reached the end of the prefix, so we will return a 0, right? Otherwise, we can return a 1, right? So let's run this. So in this particular case, we are running a for loop for all the words in the vector words, right? So let us suppose that the length of this particular vector is n, right? And then inside this here, we would be running a loop for each of the characters in our string and prefix, right? So let us suppose that that length is m, right? So we can say that the time complexity over here will be n into m, right? And we have not taken any extra space, so space is constant, right? So let's try to submit this. Now here we are having multiple approaches. For example, instead of creating this has prefix function, what we could do is that here we can use find function, right? What we can check is that if word dot find prefix is equals to 0. So this is the approach that we had followed in yesterday's problem, that we are checking that if the prefix is present in the string word, then it will return as the first occurrence of prefix, right? Now, if the first occurrence of prefix is present at index 0, so we can say that yes, word is starting with this particular prefix, so we will count it, right? So let's try to run this again. Now here the time complexity is same, and we can also use starts with function that will also return as the same thing, and the time complexity will remain the same. Now there is one more approach of solving this problem with what is known as a prefix tree or a trie. So let's look at that approach as well. So in a prefix tree or a trie, what we can do is that we can put all of these words, right? So basically, since it is a tree, we would be having a root node, right? And then we'll take the first word, we will iterate in this character by character, and we will keep on adding a node over here. So basically here the first character is P. So from here we will create a link to a node with P, right? Then next we have A. So here we'll have an A. Then next we have a Y. So here we can have a Y, right? Then we'll do the same thing for the next string. So here it is A. Now this root is not having any link to A, so we will create it, right? And then we have T, then E, then N, then T, and so on, right? Then if we come at this practice, now we'll see at the root node for P, we are already having a link. So we will not create a new one, right? So for this P, we will consider this P. Then next we have an R over here. Now this P is not having a link to an R, so we will create it, right? So it will be R, A, C, T, and so on, right? Then we'll see for this one, attend. So at the root node for A, we are already having, then T already there, then T already there, then E already there, then N already there, and then D. N is not having a pointer to D, right? So from here, we will create a pointer to D, right? So this is what our prefix tree will look like, right? Now in this, along with these characters, we can also store the count, right? Store the count meaning here n is having two links, right? So for this n, we'll store a 2, and these will also have a 2. Then here it is having only 1. So these will have a 1. Then here this p is having two links, so this will have a 2. And then here all of these will have a 1, right? So this is what our prefix tree will look like. Now for finding out our answer, what we can simply do is whatever is this prefix, we will start on iterating for these characters in our prefix tree, right? So from the root node, we'll check does it have a pointer to A? So yes, it has. Then we check for T, so yes, it is there. Now prefix is finished. So whatever is the value present for this T, which is 2, that is going to be our answer, right? Because there were two strings where this was a prefix, right? And if let us suppose there is some character which is there in prefix but not in the prefix tree, so we can say that there are no strings which are having this particular string as their prefix. So there we can return a 0, right? So this is also one of the approach. Now, how are we going to implement this? So we will have to create our own custom trie class. Basically here, if you see, each of the node will be having two things. One is the link to the child and the other thing will be the count, right? Now for link to the child, what we can do is in our words, we are having only A to Z characters, right? So for each of the nodes, what we can do is that we can create a vector or an array of length 26, right? And initially we can keep all the values as null, right? So basically for this A, we will have a 26 length links vector, which will have null pointer. And then when we want to create a link to T, so at the index of T, we will create another 26 length vector, right? So basically what I am saying is this root node will be a 26 length vector. Let's suppose this is A, B, C, then this is P, and then so on, right? All of these will be null initially, and the count will also be 0. So basically each of the node in our trie will be having two things. One is a vector of nodes. We will be storing nodes only, right? And we'll name it links, and the other thing will be a count, right? So this is what our one node will look like, right? Now here when we have created this root node, and then we'll start with this particular string. So here we have p first of all, right? So in this particular root node, what we'll do is that at p we will remove a null pointer, right? We'll remove null pointer and we'll create a link to a new node, right? A new node will be having another vector links of 26 length and a count, right? So here we will create another 26 length vector. All of these will be null, and we will increment its count by 1, right? So now when you will come here at practice, so the first letter is p. So you will see that, okay, at p, it is not a null pointer. I am already having a link to a node, right? So what I will do is I'll just update this count to 2, right? And then I will check for r in this particular vector, right? And then same thing we will do for attention, that here a, instead of null pointer, we will have a reference. So we'll have another vector which will have null everywhere, and the count will be 1, right? When we had created this. And then you have a t. So let's suppose if this is t, so from t you will have another pointer to a 26 length array, and here the count will become 1, and so on you will create, right? Similarly, when you will check for this attend, so a is already having, so you will just move here and increment its count by 1, so it will be 2, right? And then you will see that at t again I am having the link already, so I will increase its count, and so on it will go till the end, right? And then when you want to check for the prefix, you can simply come here, that from the root node I need to check link to a. Is it there? Yes, it is there. So then from this vector I need to check, do I have a reference to t? Yes, I have. And now I'm done with my prefix. So from this corresponding to it, whatever is the count, which is 2, that is my answer, right? So accessing these letters, right, inside the 26 length vector is easy. It is constant, right? Basically, whatever is our character, let's suppose ch, we can do a minus a, just this. So for a, it will give us 0, for b, it will give us 1, c 2, and so on, and z will be 25, right? So within constant time, we can access these positions in our vector, right? So now in this particular case, if we talk about the time complexity, so here we would be putting all these words inside our tree, right? We are inserting all the words one by one. So obviously this n times we would be going, right? And then for each of the word, right? For each of the word, we are iterating for each of the characters, and then we are inserting it in our prefix tree, right? So if let us suppose that the maximum length of any of the word is L, right? And the length of words array is N. So this operation will take N into L time. Building this tree will take N into L time. Then if we talk about finding out whether prefix is present here or not, so in that we would be checking for prefix, right? Basically, we will be running a for loop for each of the characters in the prefix, right? So if we assume that the length of the prefix is m, so our time complexity here will be n into L plus m, right? And if we talk about the space complexity over here, so we have built this prefix tree, and here we are having all the words, and then for each of the words we are having a node. So if here we had considered that there are n words and the length, maximum length is L, so the space complexity will also be n into L, right? So let's quickly look at the code for this approach. So here we have created our own class Trie. Inside this we have created a structure for our node, right? As I said, each of the nodes will be having a links vector which will store nodes itself, and it will have a count, right? Then in the constructor for this node, what we are doing is that we are making the links vector as length of 26, and each of the values is null, right? And then the value of the count we are keeping as 0, right? Then we have created a root node over here, so we can access it directly in our function. Then in our try constructor, in the root node, we are assigning a new node, right? So basically it will assign a vector of length 26 with all the values as null to the root, and it will make its count as 0, right? Then we have created one function add word. So basically we will give it a word and it will insert it in our prefix tree, right? So what we have done over here is that we have taken the reference of the root node in a current variable, and then for each of the characters in the words, we are checking that does the current node have a link for this particular character, right? In the links vector, we are checking at the position c minus a. If this is equals to null pointer, then that means it is not having a reference to this particular character, right? So we will create a reference. We will create a new node for this, right? And if it is not, then we will not do it. After we come out, we will move our current node to this particular character, right? Initially, our current node will be at the root. And now that we have created its reference to the character C, we will move our current node to that particular C node, right? So then we will increment its count by 1, right? Then we have another function count prefix. So we will give our prefix string over here, and it will check whether this is present in the prefix tree or not, and if it is present, then what is the count, right? So again, we have taken the reference of the root node inside cur, and then for each of the characters in our prefix, we are checking that if the current node is not having a reference to this character, basically it is null, then that means the prefix is not present in any of the strings, right? None of the strings is starting with this prefix, so we will directly return 0 from here itself, right? Otherwise, we will move on to that particular link. Basically, we are moving to the next character, right? So once we are done with this for loop, at the end, we can return whatever is the count corresponding to current, right? So if all the characters are not present, then it will be returned from here itself. If it is coming out of the for loop, then that means we have reached the end of the prefix. So whatever is in the current, we can return its count, right? And then in our function, we have just initialized this class. Then for each of the words, we are running a for loop, and we are calling the add word function, and we are passing this particular word. And then here we are calling our count prefix function, and we are passing prefix to it, so it will return us the count. So that count we are directly returning. So let's try to run this. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.